Need a progress indicator function in GP PARI? It might sound trivial, but I needed one, and PARI does have a few quirks. We can imitate the episode 3 solution for MATLAB Octave. Since PARI printf does not handle carriage return correctly, we must use the backspace technique as in episode 3. However, PARI printf does not have the backspace character. Nevertheless, we can pass in the ASCII code 8 using %c, and it does the job. And PARI does not have persistent variables, so globals will have to do. Let's get started. We make the same 3 different versions for illustration as we did for MATLAB Octave. Here is the stateless progress indicator as a one-line PARI function. It is simple but has the obvious problem of being inefficient. Here you see we pass in the value of 8 into the %c of the printf to create the backspace character. Notice that we're running progress intermittently by putting it inside the true part of the if statement. Here this loop is simply looking for twin primes. Notice also that we immediately go from one calculation to the next without any need for initializing or changing the progress indicator. This will be important for the next version. The second version adds state or memory to this indicator. PARI does not have persistent variables like MATLAB and Octave, so any memory would need global variables in a separate initialization function, as shown here. This allows for updating the progress percentage only once every 1% complete. To make it more robust, we add a percentile indicator array and a means to reset the progress indicator state, as we've shown here. Notice that progress function has the same characteristics as the one in progress 1a in MATLAB. Here, if the progress runs backwards, we run the initialization function. And here, if the particular percentage has not been printed out yet, we print it out and record that fact. Also, the test program is the same as the one before, but notice there's no initialization between the twin primes and the prime counter loops. Third version uses only one parameter, the total expected number of calls. It still prints out only once every 1% complete, but without having a percentile array. It simply has a progress counter, as well as the old total count. Notice that it uses the same technique to limit the progress lines by calculating whether or not progress has increased by 1%. Let's run all 3 examples. Notice that the first loop is a loop over the primes that counts the number of twin primes, and it counts in the forward direction. The second loop is a loop that counts the number of primes, but it counts in a backward direction. Here we go. As you can see, the progress indicator goes from 0 to 100%. That's all for now.